Welcome, everyone. Thank you for being here. I know it's been a full few days of talks, and we appreciate you spending this time with us. We hope to make it worth your while. And to that end, there's some late-breaking context that didn't make it into our slides, but feels important to share. We built everything that you'll see using dbt core. And as of last Friday, Cityblock signed a contract with dbt Labs to move to dbt Cloud. We're excited about that, and we'll highlight a couple of areas where our approach will change, but I want to emphasize that the fundamentals are the same. So whether your organization is using dbt core or dbt Cloud, we hope you'll come away with some ideas to put into practice. That said, we'll get to it. The title of our talk is One-to-Many, moving from a monolithic dbt project to multi-project collaboration. My name is Katie Claiborne, and I'm an analytics engineer at Cityblock Health. Cityblock's mission is to improve the health of underserved communities, and my part in that is as an analyst turned engineer. Maybe some of y'all can relate to this career trajectory of wandering your way back in the stack and finding a niche between the two disciplines.
And I'm Nathaniel Buren. I'm also an analytics engineer at Cityblock. I've been in the BI space for the last 4 years, turned engineer for the last 3, and I'm happily dedicated to our risk and burden of illness team. So, what are we going to talk about today? So, we're going to go over by designing a prototype dbt project, then developing the infrastructure to replicate it. Analytics engineering teams can move efficiently from a monolithic to a multi-project collaboration. So, what are some of those definitions that we just heard? So, prototype project. This is a dbt project that can be used as a template for future ones at an organization. These can contain any group of models that you want, but it has to start with a team that's willing to commit to new coding standards for quality. The infrastructure to replicate it. This is shared files and processes that enable new dbt projects to be created consistently and reliably. Spoiler alert, make friends with your DevOps folks. So monolithic and multi-project collaboration, we've all heard this word throughout this whole conference. Obviously, monolithic collaboration is where you have multiple teams working on one project. You can encounter a multitude of errors during testing, disrupt workflows of downstream teams, just awful. You've all seen the spider web gnarly mess of DAG graphics all throughout this conference. And then your multi-project collaboration, where teams can develop nimbly within their own projects, and them being their subject matter experts within that project, you can then create great consumable products for other teams to use with confidence. So today we're going to be telling our story in 3 parts. We're going to give a little bit of a view from Cityblock's perspective and the perils that we ran into with our monolithic project. We're going to go over our project in a box, the designing of the prototype, and the assembly line, how we scaled to multiple projects. And I'll let Katie introduce dbt at Cityblock.
Thanks, Nathaniel. I'll give just a brief history here as a way of illustrating some of the problems we ran into in our monolithic dbt project. Cityblock adopted dbt relatively early in June of 2019. We're lucky to have an alum in the crowd, Tommy Wu, who was a big part of making that happen. The first 2 years were smooth sailing. The project was growing, and we were enjoying the benefits of moving our analytic products into the world of software engineering. You're probably familiar with these. They include version control, documentation and testing, and dependency management. Somewhere along the way, call it 2 years in, we noticed the project starting to slow down. We had more and more models, more and more sources, and we entered what's sometimes called the trough of disillusionment. We felt like we were spending more of our time simply maintaining the project, as opposed to creating and sharing new knowledge for the organization. More specifically, we found ourselves here. So here's our version of the big, scary lineage graph. As Nate referenced, you've probably seen a few of these this week. But we'd like to highlight 3 specific problems that it created for our teams. The first is that radically different SQL styles popped up in different areas of this graph. So even though all of the files had the same .sql extension, they might as well have been written in different languages. That made it hard to collaborate. Second, there were inconsistent levels of documentation in different parts of the graph. That made it difficult to onboard new engineers because so much of our knowledge was stuck in brains rather than being documented in code. Finally, the modeling inefficiencies in this tangled graph here were lengthening our build times. That meant we were spending more of our time waiting and less time developing. The thing is, we weren't alone. DBT Labs was observing more projects reaching this unsustainable size. Jeremy Cohen articulated this problem in a GitHub discussion from early in the year. And he really hit on a lot of the pain points that we were experiencing, and he started to lay out a vision for a better way forward. Before we get too far, I want to be clear that this is not a critique of our past selves, our past teammates, or even past versions of partners like DBT Labs. Instead, I'd suggest that these are typical challenges of rapid growth. And kind of remind everybody that every team makes technical decisions at a particular point in time. So for us at Cityblock, we were an early stage startup, and it made sense to build fast and worry later. It's really only because we did that we had the chance to reevaluate at this point. So what did we do? Rather than trying to save that monolithic legacy project, we decided to try again and build a collection of smaller projects that could work together more nimbly. We made a bet that a short-term investment in prototyping multi-project collaboration would yield a higher long-term value to the organization and help us turn this curve back in the right direction. Nate's going to walk us through what we came up with.
Alrighty, so our little project in the box. This is our lonely DBT friend. He's injured, unhealthy, and this is where we realized a healthy DBT project can't exist in isolation. It needs to be part of a larger, healthier infrastructure. So this is our stack in the box, our 30,000 view, where we're using GitHub for our version control. Data transformations, we're using dbt core, obviously. Our cloud infrastructure, we're using Terraform. Our continuous integration and deployment, we're using pre-commit and GitHub Actions. And then we're using Google for our cloud platform. And then for an extended look at how we designed our prototype project, you can take a look at DBT's meetup in New York. The presentation was done by none other than Katie Claiborne, and it's a great talk. So this is a great outline of how our architecture translates into our code base, and I'll walk you through each section. So bottom left, this is our buddy Steve in DevOps at Cityblock. Remember, make friends with your DevOps folks. And this is where we're using GitHub Actions. So these are automated processes that perform a set of tasks. They're configured in our YAML files within the repository and can be triggered by a number of events. So today in Cityblock, we're using them for each of our environment: development, staging, and production. Our pull requests test changes in development, and our staging and production workflows then deploy these changes as they emerged and released. Pre-commit. So this is another automated framework for identifying defined issues in code. We use pre-commit hooks to enforce consistent SQL and YAML styles, which then promotes reliability and collaboration. It accelerates onboarding, and it also sets a precedence for our new engineers that come on and basically lets them know how we like to code. And then this also allows reviewers to focus on substance rather than style, because if you're anything like me, you're OCD and sometimes can't get past a bad PR and want to fix it all yourself. And then for more information on that, Montreal Analytics gave a great presentation at last year's Coalesce. So dbt and dbt-project-evaluator. So we should all know dbt is our command line tool for data transformations. We use a dbt init command to generate a great starter project. And then we add a package.yaml file in order to download dbt-project-evaluator. And what this does is it ensures us adherence to best practices for modeling, testing, documentation, structure, and performance. And again, Grace had a great talk last year at last year's Coalesce. Terraform. So this is our other buddy, Steve, on our DevOps team at Cityblock. So if you are thinking about joining Cityblock's DevOps team, I'm sorry, your name has to be Steve. But Terraform. So again, like Katie alluded to, we had the pleasure of working both in core and now we're working in clouds. So within core, we were able to use Terraform to configure our service accounts, artifact storage buckets, and permissions. And if you haven't heard of Terraform, this is infrastructure as a code tool that lets you define resources in readable configuration files that you can then version, reuse, and share. So very powerful. It's very nice. So we dabbled a little bit in dbt Cloud with Terraform, and we discovered we no longer needed to configure our own artifact storage buckets. And then we could also use these configurations in our projects, environments, jobs, and more. And Katie will kind of cover what's next.
Sure. So with that prototype project in place, our next challenge was really to scale it, to extend this approach to break down the rest of the legacy dbt project into that group of smaller projects that work together. And it was that challenge of scale that led us to develop something of an assembly line. Really, the light bulb moment for us was that the same principle of modularity that we strive for within our dbt projects also applies across dbt projects. And we really came to believe that in order to move from a monolithic dbt project to multi-project collaboration, some kind of infrastructure to scale efficiently is essential. So to show you what I mean, let's review how this problem can show up within a dbt project. If you've contributed to one, you've probably encountered a situation like this. You've written a model or part of a model, and you want to reuse that bit of code, but somewhere else. It's maybe at this point that you encountered the DRY principle of development, where DRY stands for don't repeat yourself. Of course, that is always an option, the old copy pasta. If you could go to the next slide, thanks. You can just copy that code and paste it in the new location and change whatever needs to be changed, but that gets old pretty quickly, and it leads to a code base that's difficult to maintain. Because if you ever want to change how that logic works, you have to change it in multiple places rather than just one. So at that point, you might have started to abstract, to put common pieces of logic into shared building blocks that can be reused and maintained easily over time. So keep these principles in mind as Nate walks you through our architecture.
All right, so this is our single project architecture. Our dbt projects live inside our GitHub repository, where we're then using Terraform to configure our resources and permissions. Each dbt project writes to BigQuery tables in our Google Cloud project. And then within each project, there's a set of environments. We have our development, staging, and production. So, project one, we started with our core team of analytics engineers. We thought we had to start somewhere, and our foundational model seemed like a good choice. And it went very well. the team was engaged, and they were willing to try something new. So that was awesome. Project 2, on the other hand, we found ourselves doing a lot of copying and pasting, and this was for our applications team. Cityblock maintains their own in-house patient management system called Commons, and so that team wanted a way to define which elements in their data models were stable enough for analytic models to use. And so what we did, we built a subset from these models from core into this new project. In the next 2 slides, we'll show you the best of both worlds between core and dbt cloud. So first thing we did to get our Commons project in there was use dbt packages within core. And if you've never used a package, these are standalone projects that includes models and macros that basically become part of your own project. With a dbt build or a dbt run, that package models, those models in the package then become part of your project. And then you can ref them in your own models. And then also the macros too in those packages you're able to use. So jump to dbt cloud where we have project dependencies. And then our clicker doesn't work, but you'll see in our code base right there, you'll see our name Commons. Very simple way to just bring that in there. And this has several advantages too. So this keeps your project narrow and avoids unnecessary resource complexities. You no longer have to mirror conditional configurations, so no longer have to update vars, environmental variables, or your target name. And then it also eliminates the risk of your project's models being built with a dbt run or a build command and prevents unexpected warehouse costs and permissions issues. So we had our project 3, and this is where we had our moment of clarity, and we committed to build our 3rd project with scalability in mind. And there's a name for this feeling, and it's the rule of 3, which states the 3rd time you encounter a pattern, you should probably abstract from it into reusable unit.
So in order to fulfill that commitment of setting up projects more scalably, we created 2 new GitHub repositories, pictured on the left-hand side up here. The first is our template repository, which contains the files needed to get a new project off the ground. The second is our workflows repository, and it contains shared files that a project, or really any number of projects, can call over time. We'll take a closer look at the distinction between these 2. Since they serve different purposes, they contain different types of files. Again, the template repository is used for one-time setup for new GitHub repositories that will contain a dbt project. It contains the files needed for local development, so think about pre-commit configuration files. You need those files on your machine if you want to run the pre-commit hooks associated with them. The workflows repository provides ongoing support for all repositories containing a dbt project. So it contains files that are needed only for remote processes and specifically for continuous integration and deployment. So think about those GitHub Actions workflow configuration files that we looked at earlier. We'll look at each repo in more detail now. So first is the template repository. Again, you see the file structure that we walked through earlier. In GitHub, a template repository is just another repository. It has a special designation as a template that allows it to be used to generate other repos that look just like it. We use the template repository as a home for our prototype. By putting the prototype dbt project into the template repository, we ensure that all future projects are created consistently in a way that's not subject to human error. So to see it in action, this is a repository that we created for our analytics team, who's consuming a lot of the models that the core analytics engineering team produces. So in the top left here, you can see that the repo was generated from the template, and then our DevOps team has created this snazzy little GitHub app that takes care of the initial commit and drops in all of the files that you saw in the template. Note that the GitHub app isn't necessary. You can do it in the GitHub UI with a few clicks in a way that's still much easier and more reliable than doing it yourself. So next, the workflows repository. Again, this contains the shared files that support CI/CD processes, and any number of projects can call the workflows repo over time. We used it as a place to put reusable workflows. So here we've pictured two. The first is a reusable workflow to run pre-commit hooks. And this reusable workflow is called by the pull request workflow in the downstream repos. The second is a workflow to deploy changed models. That one is called by staging and production workflows in the downstream repos. Again, by storing these in a central place, we're making sure that all DBT repositories are testing and deploying their code in the same way. If we ever want to change how that happens, we change it here, and all of the downstream projects inherit those changes. We can take a look at an example again from the analytics repo. So each target repository contains a set of really simple GitHub Actions workflows that are really just calling the centralized ones. So here we're looking at the pull request workflow in the analytics repo. It's a little small, but it's calling the module to run pre-commit hooks in the central repo. And it's passing in a few values that are particular to the analytics project. So this is kind of like a model calling a macro. You're passing in your inputs into that centralized logic. So we've covered a lot up here, but we'd like to end with the idea that dedicated DevOps support can elevate analytics engineering. Establishing standards for code quality and designing a multi-repo strategy can allow teams to collaborate nimbly across projects. Thank you. We'll stick around up front if you want to chat, but otherwise we'll share this information to come. Thanks.
Find your Steves.
Find your Steve.